Hello developers, let's start developing. Today we're taking on the day 7 of the 2023 Advent of Code, and on first read there's quite a lot of text that we actually need to read, but it means just that we just want to sort a set of poker hands. So we have our poker hands, we have our weights, not weights, but the bet or something like that, what is this bid amount. And then we need to determine its rank, which is basically a reverse sort of the hands. The good thing is that we're gonna need to sort them in a poker way, and I was actually implementing once in my career a poker evaluation, including strategies of what to keep and what to throw away. And we only had the have here the normal hands. So don't have the flushes or the straights or things like that. We just have the regular five of a kind, four of a kind, full house, three of a kind, two pair, one pair, and high card. So that means that all the calculations that we need to do are based on the frequency of the cards themselves. We don't have colors, so to say. So the only possible thing that can happen outside of this is, I guess, straight. But anyway, seems like a relatively straightforward task. So this is the input, and let's just take the small input once we find it. Yeah, this is our small input. And basically we have these. So the 10 is not 10, it's T. And the strengths are basically the regular strengths. So we need to read this up and parse it. The parsing it will be relatively straightforward. So we will have input dot map. So for each line, we're gonna split the line. Oh, nothing like that. I have no idea where that came from, but we will do a line dot split on a space because that's what we have, and it is a single space. So now we should just say we have two elements, and those two elements is the hand, and the other element is the bit. So just return hand and bid. Oh, the bit should be a number. So we're gonna have it like this, and the bid is the simplest way to actually get a value, which doesn't hurt to have an interface, not a point, but hand. I have no idea how to say this otherwise. Actually, maybe we want, so the card is an A or this. Yeah, obviously I'm not the first guy that actually writes cards, so this makes sense. And then we can have values, which is that could be useful, but I'm thinking of a mapping that goes from a card to a number, and then means that A is something like this. Yeah, and the rest is gonna be totally like this, so we can always do a lookup. But this is already part of the solution, not part of the parsing, so I move this over here. But anyway, maybe I don't want the hand to be a string. And I'm lagging a bit because I don't have a good name for the pair of the hand and the bit. Let's call it a poker game. Poker hand. Yeah. That it makes sense because a poker hand consists of the hand you're dealt and the bit that it comes in. Doesn't really make sense, but let's use that for now. So this is not a string actually, this is a set of an array of 5 cards because we're not gonna work with it as a string, we're gonna work with it with a set of 5 cards. So if we split it on a space, now we have our array of poker hands because we're not gonna use a string array. We're gonna use a poker hand array here and here and here and here. And that should be it. The process input should return not the input, but the hands. Okay, I feel that we might be done with the input, but just console log the input. So let's see what we get. npm start 7. Let's see, we're loading the code. Let's compare it with input 32T, 3K, 5, T55, J5, KK677, KT, JJT, QQQJA. The bits are 28, so the one that has only 2 digits is parsed correctly. So, yeah, we get the correct input. So now we just need to sort them. That's kind of all that we need to do. So const results are input. So I'm not going to use the sort method. I'm going to use a fresh new JavaScript 2023 method that's toSorted. This is non-mutable. So this won't mutate my input. This will mutate only, this will return a new array which is sorted. Otherwise, it's just like sort. So we're gonna need to provide a comparer that says we have a first hand, poker hand, and a second poker hand, and we just need to compare them. So yeah, this says you can compare them by a bit. That's great and wrong. But we do want to actually evaluate the hand. So that means that we're gonna need to have another type which is gonna be evaluation or hand actually. Oh, it provided some things. I'm gonna write it like this. And to be honest, this is totally valid. We can use strings with spaces on them, but my developer heart kind of jumps when it sees a space in a constant. It says, "Oh, this will be a problem." So We'll do it like this, and hopefully, yeah, it will generate it in the correct way. So again, there's just no difference between that and this. Only my programmer brains marks this as correct, but marks the other one as no danger. Otherwise, it's okay. So let's just see if we have all of the types that we have and only the types that we have. High card, one pair, two pairs, three of a kind. We don't have a straight, we don't have a flush, we have a full house, we have four of a kind, and we have the five of a kind. So we're gonna need, yeah, those are the hand types, and we're gonna need another function. Actually, we can define this. That will be a record that will say that these are the values. High card, one pair, two pairs, three of a kind, full house, four of a kind, five of a kind. These are the type values. So we will just need one more thing. So now we can write one more thing, which is a function. Get hand type that will take out a poker hand and return a hand type. And let's say return high card. This is a dummy implementation. So now we can say const f type is the get the type of the first one. Of course, get the type of the second one, and then say if the first type is bigger than the second type, return 1. If the second type is bigger than the first one, return -1. So they'll get sorted. And what happens if they have the same? Well, we'll need to break any ties because any two hands that are not identical can actually be sorted. But for now, let's do this because I want to implement the get hand type thing. So the poker hand, actually for the, oh, yeah, might need something like that, but I can just add the hand here. So I will add another type that I will just call hand, not poker hand because we already used that. Or we just call this is a bidded hand and this will be a poker hand. So a bidded hand is a poker hand and a bid. To be honest, we have way too many hands. So we're not taking a bidded hand, we're taking a poker hand because the bid is totally irrelevant. So what we need to do is we need to group. Since all of them are just counts, we will need to group them. And I actually have a method for that called group reduce. And we're not gonna use this implementation, but we will use something like this. Yeah. So we're gonna start with an empty object, which will be the what we need, a record of a card towards a number. And each time, so the accumulator is, oh, what is the third parameter? It incorrectly assumed what I want. So For the group reduce, we need three arguments, and the first argument is how to get the key. And that in our case, since we have only the hand only consists of cards, is for every card, get the card. And then we have a reducer. And that reducer basically tells us, yeah, this is a bit of a complicated method, but what it will do, it will group multiple elements together and then reduce them to something. Because what I want to get is, so basically, what I want to get is a code that will take this and return this object that will say you have 4 A's and one 8. So I will just do that, do the counting automatically. So it says if we have the current value of that is that or 1, 0 plus 1. Yeah, that will work. Let's write out the reduced and just return the high card so that it works. So let's see what we have. If we get that, so for the first hand, I think I messed up the reducing. Otherwise, it says we have a single P. Oh, we are messing up. Some weird things are showing up. Says we have a K and a 6 and a 7, so this one is okay. Oh no. Okay, we call them in a different way. So because sort is calling them whenever it feels it should be, we don't have the actual implementation of the sort. The first one is actually T55J5. So it has one T, one J, and three fives. And this is the 32 T3K because it has two twos, and then we have all the other hands. Yeah, note that some of them were called multiple times. That's another thing to do because get hand type is actually called insert the sorted, and we might not want to do that. Let's fix this because this means that it will not be performant. So let's fix this. Let's get that. Let's have this running, and then I think that I will use the Schwarzschild transformation to compute the Schwarz, and that then avoid recalculating this all of the time. Because this will actually be called, instead of n times, it will be called n log of n times, which is not a huge number, but it might get significant eventually. So we are getting the reducer, but I kind of dislike that the value is that object. I think that I kind of overcomplicated it. And the reducer should just be basically this. And then we're starting with 0. Because the grouping occurs on each of the items. So I created a record that I previously ensured that it will only have one thing. So this is better. So that means we have a 1 and 3 and 1 and 1 and 2 and 2. And yeah, that's what we need. So now we just need to run some checks. the reduced is an array of key when the key is a card and a value that is a number. So that means if, so now we're gonna say if reduced dot length is equal to 1, that means that we have only one item in those 5 cards. So the only way that that could happen is it will be 5 of a kind. Otherwise, if the length is 2, that means we have 2 items. And we can have 2 items in 2 distinct ways. So they can even be combined 4 and 1 or 3 and 2. And we have our cases. So that's basically it. So the first and the second, but not the first of 1, but the first dot value is 4, or the second's value is 4, then it's a 4 of a kind. Otherwise, if it's not 4, it has to be a 2. So if the length is 3, that's complicated, but if the length is 4, yeah, we'll see about that. Yeah, actually, it might have guessed it correctly. If we have 3 items, they can be 1, 1, 3. That's the one option. And the other option is that we have 1, 2, 2. Those are the only options, basically. Otherwise, we have that. So let's check once more if we covered the cases. So let's detect. We're detecting 5 of a kind, we're detecting 4 of a kind, we're detecting a full house, 3 of a kind and 2 pairs will both have 3 items. 1 pair will have 4 items and high card will have 5 items. Those are the things. So yeah, this is a long-winded and kind of hard-coded thing, but we are doing a hard-coded thing. So hard coding it is not a problem. So if one of them, the first one, the second one, the third one is 3, then we have 3 of a kind. Otherwise, we have 2 pairs. So if we have 4, then it's 4 pairs, and otherwise we have 5, and that's a high card. So this getHand type will actually return the type. Let's log the results and see what happens. The results should be a sorted array by hand type. If we have the same type, they will be the same, but with, yeah, something is different from the input. So first we have a pair. I have no idea what I'm looking at, so I will say this. No hand dot join with the nothing in between. Then we can don't have want to the bit, but we can have the getHand type of the hand dot hand. Yeah, whatever we do, we're gonna have that hand dot hand thingy, which I don't like. Actually, we can do it, avoid it if we add some complexity here. So we're restructuring from the get-go. So that looks better, and I kind of understand what's happening. So we will get our hands. We have 1 pair and 3 of a kind and 3 of a kind and 2 pairs and 2 pairs. On one hand, the detection is okay, but Validation is not because I forgot. I'm comparing the hand types. The hand types are strings. So I just don't need get hand type. I also need to map it to the value. Get the type value for that hand. So I was just comparing strings. And of course, two pairs bits. And now we have a nice sorting. One pair, two pairs, two pairs, three of a kind, three of a kind. Let's actually try this on the big input, because there are plenty of scenarios that we don't have here. So let's try that. And that actually has how many? 1000 pairs. So we will get to see the first few, which are all of them high cards. So we will need some other code if we want to actually look at all of them. We will need to not to log a, but we can just say, yeah, log all of them individually. And since there are 100 and I don't really like scrolling on the console, I will do it this way. So this will generate the output into a file, and then I can use my regular editor to take a look at that file. So we have high card, a lot of high cards, of course, and then we have one pair and two pairs and three of a kind and a few different three of a kinds, and then we have full houses. Yes, those look like full houses. We have four of a kind, and we have just a single five of a kind. Okay, that's cool. Seems to be working. Now we need to do the to-do part. And one thing that we should take care of, that this kind of breaks the regular poker behavior, because if two cards have the same time, a second ordering rule takes, start by comparing the first card in each hand. The first card, not after we sorted it as we would. So on this card, the first card is a 3. So we have both four of a kinds. We have four threes and four aces, but the first card in the four aces is a 2, and that means that the four threes beat four aces, which is not a thing that happens in regular poker, but is a thing that happens in this kind of poker. So if this means that if we get to here, we can say, no, we're not comparing the bits. And since we know there are 5 items, I'm going to do a loop unrolling. So I will say we have the values. I will get f values are first dot hand. I might want to use some more destructuring here. No. Map it, do not sort it. Please do not sort it, because if we sort it, it's gonna break. And then have the same thing for that. And now, no, don't sort them. We can say for, actually we're gonna need an index. And we're gonna need exactly this. We're looping through from 0 to 4. we are checking if the first values is bigger than the second values, we're done, return 1. If the first value is bigger than the second value, we're done, return 1. Otherwise, that means everything is the same. We have the same value, we have the same 5 cards. That means they are equal. If they are equal, they are equal. So let's start it once more on the big input and see if we get something interesting. So 4 of a kind. So yeah, we can see that all over queen 4 of a kind are falling to a king's forward 4 of a kind. And notice that this one is not a king-based 4 of a kind. And it's not 4 kings, it's 4 eights. And then we have 4 threes that are beating 4 kings. But it kind of looks sorted. I'm not gonna check each and every one of these because, yeah, sorting is kind of sorting. And yeah, this is the suckiest array, this is not, and so on and so forth. So I will just do the work now. Let's see, we don't need the console logging, but we do need to do some things with the results. What do we actually need to do? And let's go back to the small input so that we can check that we're actually calculating whatever it is. So the rank, we need to multiply with the bit. And the rank in this case is basically the index plus 1. So we're gonna need to say results dot sum everything, and we're gonna have a hand and an index, and we're gonna need to transform the hand and the index, the bit times index plus 1, and that's it. Again, sum is one of my other helper functions. So this is just a result. And let's see if that actually gives us something. Oh no, I don't want to have it in a file. I want to look at it and feel it. Especially as we turned out all the huge console logins. It says 6440. And we were supposed to get 6440. Okay, now for an unoptimized thing. Let's have the 1000 input and sum it up. So for 1000, it will actually call the get evaluation of the card something like 3000 times or 4000 times. I think. So we're getting a number that is kind of biggish, but this thing says it's correct. Let's go to the second part. One additional rule. Jacks are wild. Wild cards that can act whatever card could make the hand the strongest type possible. Oh, to balance this, J cards are now the weakest individual cards, weaker even than the two. The other cards stay in the same order. Can pretend to be whatever card is best. QJJ, Q2, 4 of a kind. Two hands of the same type. J is always treated as a J, not the card that it's pretending to be. So JQQQ2, which is a 4 of a kind, is weaker than QQQ2 because J is weaker than Q. Okay. Let's see R. So two pair are now all 4 of a kind. This one starts with a 10, this one is 4, and this one is the strongest. We will need to implement jokers. So first thing that I will do is kinda one of the reasons why I love JavaScript is because we gonna need, aside from the type values, those stay the same, we're gonna need the values and the get hand type things to actually be specific to part 1. So I'm just gonna take them and paste them inside the part 1 method. So they will be internal to the part 1 thing. And this works in JavaScript. A lot of other languages will just say, what are you doing? You cannot have a function inside the function. And JavaScript says, why not? And TypeScript as well. So first of all, this means that we will need both these things here. And since the second part is actually the same as the first part, you may see that this part actually does not suffer any changes. So this is we can extract this part now. Yeah, I'm doing a bit of refactoring. So yeah, let's have it like this, and then we'll do some changes. And now it says, okay, we don't need the first and second because we already have them. We don't need this. But it does say that it needs the type values. And since those are the poker hand, oh, it has the type values, but it doesn't have the get hand type. So now it means that this is if we had those two things and we can specify them, then basically this would work. So I will wrap this into another function that will return a function const get comparer, and that will take not a hand, but that will take the what we need, the get hand type, which is a method you shut up, you'll come later, which is a method that takes a poker hand and returns the type of hand, and it will need the values, which is a record of a card and a number. And that's all there is. So we don't need this and we need this. So this is a function that takes two parameters, get hand type and values, and then it returns this thing as a function. So get compare is actually a function generator. So we will create a compare hands and then we'll just return it. So now we will need to const compare hands is get the comparers using these two methods. And then we just say, well, this is the comparer that you're gonna use. Why is it bitching? This compare a poker hands. So we're gonna need to write a bit of code. And I like it this way because here we still have the ability to use compare hands, but the compare hands itself is relatively more simple. So now it turns out that this part of our code is kind of generic, and we will only need to change whatever we want to change in part 2 in two places. Everything is the same. We just need to say what are the values, and that part is kind of easy because we're just saying that the jacks are wild and we're not doing any adding or subtracting or anything like that, so this will just work. Now we're saying that the jacks are 1. Just to make sure, J cards are now the weakest individual cards, weaker even than 2. Okay, so they get assigned a value 1. And now, this is the actual task. Evaluate a hand that has jokers inside of it. First of all, we're gonna reduce the card. And now I will just say, if reduced find me a card when the card value is 5. No, this is equivalent so with if the length is 1. If actually I can say every card when the card dot key is not a J, then all of this works. Actually, I think I will extract this, since if we have 5 J's, it's still 5 of a kind. It doesn't really matter which one. It's the weakest 5 of a kind, but it's a 5 of a kind. But otherwise, if we don't have a joker, well, we are back to the regular way of doing stuff. And this will always return, which means that now here we do have a joker. And now we're gonna need to do some analysis, and I'm gonna go it the other way around. So if reduced dot length is 5, so oh no, if we have 5 different cards and one of them is a joker, of course we can count that as a pair because we can pair it up with any of those. One pair. Otherwise, if we have 4 topics, that means that we have to have 1, 1, 1, 2. So we have two options, that we have 2 jokers and then we can pair them off with one of the other guys, giving us 3 pairs or 3 of a kind, or we have 3 different cards and 2 jokers and we can pair them off again, or we have a pair and a joker. And so if I'm not wrong, this will be 3 of a kind. And now comes the hairy ones. I totally have no idea if this is correct. It might be, but I don't have the confidence. So we have 2 options for 3. It's either 1, 1, 3 or it's 1, 2, 2. If it's 1, 1, 3, actually this might make sense. If it's 1, 1, 3, and this line of code actually checks for that, if there is a 3 anywhere, then the rest of them have to be 1. Then we have 2 cases. Either we have 3 J's and 2 separate cards, and those are 4 of a kind, or we have 3 same cards and a J and the joker, and that's again 4 of a kind. So this line is correct. This line is not, however, because this is the other case, and the other case is 1, 2, 2. So if we have 2 cards that are not jokers and another 2 cards that are not joker and a joker, that's a full house. But if we have 2 cards and 2 jokers and the 5th card, sure, we can map it to a full house, but we can also map it to a 4th kind, which is better. So it means that we need to say, if we now need to do a lot of ugly ifs here, because actually I will just say reduced dot find which one is J. And we know that we have a J. If we don't have a J, it's not going to be here. These are the jokers. And it's going to say that it's undefined, but it cannot be undefined because we know that. And say, if we have two jokers, then it's not going to be full house, it's going to be four of kind. And if the value is not 2, it has to be 1, because it's not 3. We took care of that, and otherwise it's a full house. Now, if we have two different, this is easy. If we have only two different things, we can have the 3-2 combination, which is 3 same cards and 2 jokers, or vice versa, and that's 5 of a kind, or 4 and 1, 4 identical and a joker, that's 5 of a kind. So this is basically this. And if we have that comparer and everything else, so now we're just gonna go to the small input, see where I forgot to add something. Oh, now this thing bitches because we don't have an escape clause, but I will add this here now. Because we're going from 1 to 5 for the joker, for the non-jokers, we're going from 5, 4, 3, and 1 is already covered, and the only other options is that here we have a 2. We could have swapped it around, but it's gonna be complicated and ugly either way. But the good thing is that this complicated and ugly and poker specific logic and joker specific logic is all of that is wrapped inside this method and it's hidden away. And we can even get that as a dependency, so you can see that the comparer, the actual sorter, doesn't even really care. It says, well, I will give you a hint and you give me back what type it is. How you do that? Deuces are wild, jacks are wild, who cares? That's your problem, that's your rules. So we're gonna start it. The first part is 6440, the second part should be 5905. And this thing says it's 5905. So let's see if our proper architecting, proper management actually managed to get the correct number, because if it's not correct, we're kind of messed up because it will take a lot of time to debug what actually got wrong. But the moment of truth says that this is the right. And now we have all the 14 possible things. We are actually on the sand island or on the desert island. So we started off from the trebuchet from the ground, went to the cloud island, to the island, to the desert island, and we're gonna see where it takes us tomorrow. It's gonna be again on the desert island. So some more camels related stuff, I guess. Anyway, don't forget to click the buttons below and keep developing.